Hello class, my name is Derek, and for the Geometry Screencast, I'm going to be investigating choice 3 here, which says, below is a picture of hexagonal stones tiling an outdoor patio. Explain why a regular hexagon makes a good tessellation, but some other polygons, such as a regular pentagon, does not. Create a sketch to illustrate your explanation. This investigation follows pretty closely with some 8th grade Common Core standards. As we can see here, the first one, verify experimentally the properties of rotations, reflections, and translations. Number 2 here, understand that a two-dimensional figure is congruent to another if the second can be obtained from the first by a sequence of rotations, reflections, and translations. And the fourth one here, understand that a two-dimensional figure is similar to another if the second can be obtained from the first by a sequence of rotations, reflections, translations, and dilations. So, let's get into the investigation here. As you can see, I have already constructed 3 hexagons that are all connected at one point. And if we were to continue this, for example, create a regular hexagon right here, then you can see how the tessellation would continue on. So, as I have already measured the interior angles of each hexagon, we see that the interior angle is 120 degrees, and when we put 3 of these angles together, it makes a perfect circle. This is why a hexagon is able to make a pretty good tessellation, because 120 degrees is a perfect factor, or factors perfectly into 360 degrees, which is our circle. So we're able to take the hexagon and rotate it around a point in order to get 3 different hexagons that create the tessellation. Now, moving over here to the pentagons, you can see that after I've constructed 3 pentagons, each interior angle measure is 108 degrees. And the sum of the 3 108 degrees is 324 degrees, which means that subtracting it from our 360 degrees, the measure of this exterior angle from all the pentagons is going to be acute, which, as we can see, is 36 degrees. Since this angle right here is not equal to 108 degrees, we are not able to put another pentagon within that space. Thus, using a pentagon is not good for creating a perfect tessellation such as the hexagons over here. Now you can investigate other shapes as well, and you'll find that the only shapes that work well for tessellations are shapes in which the interior angles are a perfect factor for 360. Let's try it with 3 heptagons, and we'll see that there's some overlap here. That is because the measure of the interior angles at which these heptagons are connected is 128.57 degrees. Since we try to connect 3 of these heptagons together, we know that the measure is going to be greater than 360 degrees, which is why we have that overlap between these 2 heptagons. So, as I've stated before, the best polygons to use as tessellations would be polygons in which the measure of the interior angle is a good factor of 360 degrees.